Today we are calculating a statistic called combinations. And what a combination is, it's where we take a selection of objects where the order in which we choose the objects is not important. So it's the opposite really of permutations, where the order of the objects is important. So when we take a look at a permutation, we know order always matters, and each different way we can arrange it affects the number of arrangements we have. So if I have the letters A, B, and then I arrange them as BA, those are two different ways we can arrange that. So those are not the same thing. But in a combination, the order doesn't matter. So A, B, and BA are exactly the same. That's one arrangement of them. Now, where do we find this in math? Well, I always think of the committee problems. If we had a committee made up of Sue, John, and Ben, it doesn't matter the order that I arrange those names. It's still the same committee. And that's that idea of what the combination is. Now, when we go to use combinations in math, the thing is what they're going to do is they're going to give us too many members of the committee. So it'd be something like this. I have 4 people that I want to make groups of 3. How many combinations can I make? So again, I'm not going to use all the people. Well, when we go to do this, it's kind of a cool looking equation. We have n factorial divided by r factorial times n minus r factorial. Very cool. What do those letters mean? Well, the n means the number of total people that I have that I can choose from. R means the number of people I will choose. So in this example, I have 4 total people that I could choose to put in the groups of 3, which would represent my R. So then, when we go to fill this in, the 4 goes on top, and remember, it's 4 factorial, which means it's 4 times 3 times 2 times 1. Underneath that, I want to do 3 factorial. So I have 3 times 2 times 1. Then next to that, I want to do the 4 minus 3 factorial, which is 1 factorial, which is 1. So that bottom part is where we really have to put that whole thing together. Now, again, I want to cancel out whatever I have in common on the top and the bottom. So when I go to do this, I see I have a 3 in common, and 3 divided by 3 is 1. I have a 2 in common, and 2 divided by 2 is 1. I have a 1 in common, and 1 divided by 1 is 1. So they disappear. So really, what do I have left once I've canceled those out? Well, I have a 4 on top, and I have a 1 on bottom, and 4 divided by 1 is 4. So I have a total of 4 combinations of the way I could combine those people in groups of 3. So if I want to choose the probability that I chose that exact group that I ultimately used, well, there's only one group I'm going to use out of the 4 options I had. So combinations give us far less options than what a permutation gives, because the order does not matter in this. And so today, you guys are going to be working with combinations. Don't let this equation kind of worry you. Remember, all you're doing is filling in these numbers exactly in the way that they show. The total number that you're choosing from is on top. The number that you're going to be putting into groups would be on bottom, and then you subtract those 2 with that. So have fun with this. I think this is a fun concept to work on. Good luck.